Hello everyone, welcome to the review of the Modular Pipeline Library. This is a boring video about what you need to know before go to the fun demo videos. So sit tight, it will not take too much time. In this presentation we will see the benefits of the Jenkins pipeline engine. I will introduce the MPL and why it was created. You will hear about the library structure, a couple of words about the nested libraries based on MPL, and last but not least, how the development process is going on and something about testing. After that, you can ask me 4 questions, which I will not hear, seems like it's a good part. But anyway, you can check the other videos about the MPL and leave some comments under the videos. I will try to answer all the questions as politely as I can. Okay, now it's time to talk about Jenkins and DevOps automation problems. I think the pipeline engine in Jenkins, the pipeline jobs in Jenkins after 2.0 is created to help us to go away from this mess with multiple freestyle jobs connected no one knows how. Because Jenkins is not completely about automation. It's also about the interface to show the others that automation is working as expected. And what are we getting with the freestyle jobs? Yep, a disaster that is hard to control and maintain. And nothing could help with that. Even job DSL becomes hard to support and doesn't describe the pipeline itself. I assume here that you know what we are talking about, because if not, it will be hard to explain, so just return when you will read about the stuff. So, as I said, we need to go further. To the real programming, and any automation is a program after all. Enough to hide logic under the DSL. Simple and clear interfaces is what we need to finally clarify the automation. The pipeline engine provides a pretty simple way to describe your automation, and if you want, go deeper into the Jenkins to release its power. And it will look pretty. Developers and management will shake your hand, because finally you can explain your automation. Yeah, I'm joking. But at least it will look much better. All the information you can store in the build and show on the dashboard. And all the automation as a code and automation unit testing is really here. Your teammate reviewers will thank you. Of course, when they will learn the pipeline syntax and if you will organize it right. And this task, my friend, is not so simple as you think. I saw many pipelines and most of them are not really useful. For anyone else, it's hard to reuse experience, because logic is just laying in the shared libraries as crappy created steps. And if you have a number of DevOps teams in the company, it's a dead end. When I thought about that, I found that no one had time to really think about the architecture of the pipeline logic. And that's why we are here to check out yet another approach. Yeah, another standard, but as usual, we just need to try. The MPL is a shared library for the Jenkins pipeline engine. It could be used directly from the Jenkins file, pipeline script or another shared library, and could really simplify your DevOps life. This library allows to store your logic as standalone models that could be connected with each other and could be overridden when you want to. It already contains default pipeline and a couple of models, as a simple example for you. But overall it's just an interface to create your own library. Also, out of the box you will find a unit testing framework for the models and the ability to distribute the pipeline development across the organization by using nested libraries. Also, it has pretty good documentation, including README, wiki with examples, and a number of videos on YouTube. Oh, almost forgot it's completely open source, so use it as you want and contribute if you need. Okay, it's time to talk about the real stuff, structure of the library. The library consists of 3 main parts: pipelines, models, and functions. Pipelines describes default configuration and pipelines itself. They are stored as steps and usually executed directly from the Jenkins file. Models are bricks of pipeline. We're just storing some logically completed action to the model and creating a configuration interface for it. Big models using smaller models to organize all the actions, so finally we're getting a tree of models to use them in the pipelines. And last and lowest level part is functions, organized as pipeline steps, doing all the dirty and hard work for us. MPL already has a number of such routines to make it work as a framework. And you can use each part separately if you want, but you can get the most out of it if you will use them together. Also, the MPL is not forcing you to use some ultimate pipeline, but providing a way to build your own and use across your projects. Now, how to use it. Here you can see two ways. You can load the MPL directly from a Jenkins file / job pipeline script, or use it as a part of middle layer nested library. When your project is small, it's better to use MPL as is. But when you need some additional powerful moves, or you have a number of projects to support, it's better to store your automation in the nested library. Nested library in general is a Jenkins shared library too, but it's using the functionality of the MPL. Could override it and store your own models and functions you need. Overall process looks like I described here. MPL is not managing a job generation, so you still need to create a pipeline job on your Jenkins. After that, you choose where you will store the project automation configuration. I could recommend to use Jenkins file in the project repository to allow developers to use your pipeline configuration interfaces. It will contain only library and pipeline call with configuration, so developers can handle that. But if you want to get maximum control, do it in the job pipeline script. Next, you need to choose a pipeline. It could be a custom pipeline stored directly in Jenkins file, default pipeline from the MPL, or your own from nested library. Describe your pipeline as you want, in declarative or scripted style. From the pipeline you can call modules, which could be placed in MPL, nested library, or directly in the project repository. Very handy when you need to adjust or test something. The modules can call each other, so you can use functionality of an already overridden model. Lastly, you can call functions or steps from the modules, or from pipeline of course, to fulfill your automation with tricks and magic. Now let's talk a bit about the modules model. A module is a simple part of a pipeline with steps which have a provided configuration, same environment and restrictions as the parent pipeline, but it's independent from the other logic. So you can use all the same pipeline steps like in the usual scripted pipeline environment. Modules are the most advanced part of the MPL because they have the ability to be overridden and inherited by the other models. Let's look at the picture. If we have just one model with the name sample model, for example, you can call it just that. But if you need to change the logic for some standalone project, you can just create a model file in the project repository with the same name, sample model, and it will override the original model. If you don't like how the model is working, you can just override it with your own logic. Also, if you want to do some actions before the original model execution, you can override the model, put the actions into place, and after that, call the same model name. The MPL will detect that you are already using such model name, find upper level model and execute it. The same way you can alter the configuration or add some logic, execute model only if file exists, and so on. This inheritance model working across the project and nested library is so you have almost infinity number of ways to make your pipeline really advanced. The next thing I want to show is the pipeline model for one of the examples, Petclinic Selenium. We have a separate demo video about it, but here I want to show how models overriding and inheritance is working. Okay, as you can see, the pipeline has 4 stages. Each stage is called a default model based on the stage name. The first stage is checkout, so it's called the checkout model. The model from the MPL is not overridden and executed as is. This model calls the default checkout model to get the project sources. The next stage is build, and the build model is overridden on the project side. Actually, you can't override models on the project side until checkout, because workspace is empty. The build model is overridden because we need to inject the Docker build model after the default build. So we call the same build model. It's executed from the MPL as is, and after that we call our project side Docker build model to perform Docker image creation. And this is how it works. No magic, just logic. It's pretty much the same for the rest of the stages. I think that's it about the models. There are also a couple of additional things, but you can find details in the documentation. Let's talk more about the nested libraries. As I said before, Nested Library is a Jenkins shared pipeline library that uses MPL features. The main point in introducing such nesting was to distribute pipelines development across the multiple teams. Any company has multiple teams or departments, and they are usually looking for someone's standard automation pipeline. But the real world is not perfect, and each one needs some tuning for the pipeline. As a result, we are getting a configuration chaos and erosion of the pipeline logic. Waiting the core team to make some changes in the pipeline is exhausting, so other teams can use the nested library to implement some features immediately and test them. After stabilization, the changes could easily be migrated to your MPL fork supported by the core team or community MPL as models or features. In the nested library, you can use your own models path and force some rules for the project which are using the library. You can easily override pipelines, models or functions, implement your own unit tests, even use Jenkins as you want and create your own custom steps. So I hope you got the point. Now it's time to turn to the development and testing features. Jenkins shared libraries gives us two nice tools to create and debug the pipelines. It's setting version of a library while loading and replay the run of pipeline. The MPL also provides the overriding way. You can put model with the same name into the nested library or project to play with the logic. So I think it's clear. You are just creating your own feature branch and creating pipelines, models, anything else. The better way for community MPL is to leave it simple for everyone, but core functionality could grow. We already have a couple of feature proposals in the GitHub repo. Next possible plans is to create Jenkins plugin with implementation of the core MPL functionality, but as a side project. A couple of words about testing. Unit tests are based on the modified Jenkins pipeline unit framework, and models could be tested as a black box with mocked functions. It's not so hard to create model unit tests, just check the examples we have. Jenkins shared library is used as source code, but we build in the MPL jars to reuse the code for nested libraries unit testing. The MPL jars containing source code and testing classes for unit tests. This slide shows us the MPL repository structure. It's pretty common for any shared library. The vars directory contains interfaces. You will find here pipelines and routines for everyday use. The SRC directory contains low-level MPL classes and functions to manage the pipeline process. The resources directory contains models which are used in the pipeline. The models has a special naming convention to put them into a specific folder. For example, we call model supermoven build. So the runner will find directory build and will try to find the file named supermovenbuild.groovy in it. I think it's a small but useful change to separate build models from test models. And last directory is test, contains the base testing classes and test cases for the models. In the repository you will also find readme, mavenpom.xml to build the MPL and test it, and Jenkins file with a simple pipeline for the MPL, which is described in the next MPL build video. From the DevOps perspective, I can say that MPL has really simplified my life and gives me a ton of fun while I create automation. I can solve interesting tasks easily using Groovy magic and can't say it's impossible anymore. And suffering from creating another tricky workaround because Shell Python can't handle it is no longer an issue. We increased our stability by unit testing, and our pipelines and changes are looking clear for the future support. When I'm facing an issue, I can easily reproduce and debug it, thanks also to Docker dynamic agents. Maintenance of the pipelines are no longer hitting me hard, so I'm pretty sure we are going in the right direction. Okay, we just passed through this boring presentation. I hope it was not so fast, but you can watch it again if you want. Now you can check the other videos with more or less real demos. Just check the description to find the links. And of course, I'm waiting for your comments with criticism and questions. Thank you, and have fun!